Hello Eagle Targeters, welcome back to our channel, where we consistently deliver the latest and fastest updates in the field of current military affairs.
The F-16XL, an experimental variant of the F-16 Fighting Falcon, stands as a testament to the relentless pursuit of aeronautical innovation. Developed by General Dynamics, this unique aircraft was designed to push the boundaries of military aviation. It featured a cranked aero delta wing, carbon fiber skin, and an impressive array of 27 hardpoints for armaments. Despite its technological advancements, the F-16XL ultimately lost to the F-15E Strike Eagle in the Air Force's Enhanced Tactical Fighter program. However, its legacy endures, influencing subsequent F-16 models and contributing to aeronautical research under NASA's guidance. The cranked aero delta wing was the defining feature of the F-16XL. This wing design was intended to enhance lift, range, and payload capacity, offering significant improvements over the conventional F-16 Fighting Falcon. By extending the fuselage by approximately 56 inches and incorporating advanced materials like carbon fiber, engineers achieved a lighter, more agile aircraft. The cranked aero wings provided superior aerodynamics, allowing the F-16XL to outmaneuver and outperform its predecessors. The cranked aero delta wing is characterized by its unique shape, which combines the benefits of a delta wing with additional structural modifications. This design improves the aircraft's lift-to-drag ratio, enabling more efficient fuel consumption and extended range. The carbon fiber wing skin not only reduced weight, but also increased durability and reduced radar cross-section, borrowing concepts from stealth aircraft technology. This innovative approach showcased the potential of integrating advanced materials into fighter jet design. The F-16XL's cranked aero delta wing provided several advantages over traditional wings. These included enhanced stability at high angles of attack, improved maneuverability, and greater payload capacity. The design also allowed for a more streamlined fuselage, reducing drag and increasing overall efficiency. These benefits made the F-16XL a formidable contender in the Air Force's ETF program, highlighting its potential as a next-generation fighter aircraft. In the early 1980s, the United States Air Force launched the Enhanced Tactical Fighter program to find a replacement for the aging F-111 Aardvark. The program aimed to develop an aircraft capable of performing both air-to-air and air-to-ground missions effectively. Two main contenders emerged: the General Dynamics F-16XL and the McDonnell Douglas F-15E Strike Eagle. The competition was fierce, with both aircraft showcasing advanced technologies and capabilities. The Air Force's decision to select the F-15E Strike Eagle over the F-16XL was influenced by several key factors. The F-15E's lower development costs, perceived future growth potential, and the advantage of having two engines for increased survivability and payload capacity were significant considerations. Additionally, the F-15E's established production line and proven performance played a crucial role in its selection. Despite the F-16XL's innovative design and superior performance, these practical considerations ultimately led to the Air Force's choice. Cost and risk were critical factors in the Air Force's evaluation process. The F-16XL, while technologically advanced, represented a higher financial investment and development risk compared to the F-15E. The established production infrastructure for the F-15E, combined with its demonstrated capabilities, made it a safer and more cost-effective option for the Air Force. This pragmatic approach underscored the importance of balancing innovation with feasibility in military procurement decisions. After the F-16XL lost to the F-15E, the two prototype aircraft were transferred to NASA for aeronautical research. This transition allowed the innovative features of the F-16XL to be further explored and developed. NASA utilized these aircraft to study advanced aerodynamics, flight control systems, and other cutting-edge technologies. The research conducted with the F-16XL prototypes provided valuable insights that contributed to the advancement of aviation science. The innovations introduced in the F-16XL were not lost with its defeat in the ETF program. Instead, these advancements influenced later models of the F-16, including the F-16CD and the F-16EF Desert Falcon variants. Features such as enhanced wing design, advanced materials, and improved aerodynamics were incorporated into these subsequent models, improving their performance and capabilities. The legacy of the F-16XL lived on, proving that its development was not in vain. The F-16XL's contributions extend beyond military applications. The research conducted by NASA using the F-16XL prototypes has influenced modern aeronautical engineering and design principles. Innovations such as the cranked aero delta wing and the use of carbon fiber materials have been applied to both military and civilian aircraft, demonstrating the broad impact of the F-16XL's technological advancements. This legacy underscores the importance of experimental aircraft in driving progress in aviation. The F-16XL is an experimental variant of the F-16 Fighting Falcon, developed by General Dynamics. It features a cranked aero delta wing, carbon fiber wing skin, and an extended fuselage designed to enhance lift, range, and payload capacity. The F-16XL was developed to explore the benefits of advanced wing design and materials, and to compete in the Air Force's Enhanced Tactical Fighter program as a potential replacement for the aging F-111 Aardvark. The main features of the F-16XL include its cranked aero delta wing, carbon fiber wing skin, extended fuselage, and the ability to carry 27 hardpoints for armaments. These features provided significant improvements in lift, range, and payload capacity. The F-16XL lost to the F-15E Strike Eagle due to factors such as the F-15E's lower development costs, future growth potential, and the advantage of having two engines. The F-15E's established production line and proven performance also played a crucial role in the decision. After the F-16XL lost to the F-15E in the ETF program, the two prototypes were transferred to NASA for aeronautical research. NASA utilized these aircraft to study advanced aerodynamics and flight control systems, contributing to the advancement of aviation science.
Thank you for watching. Hopefully, this show can broaden the knowledge for you and your family. Don't forget to like, comment, and subscribe to help grow this channel even bigger.